We have all heard of this. You cannot compare oranges to apples. They are simply different, right? What does this mean? Is that really true? We actually can use a technique, we call that a factor rating, to compare oranges to apples to some extent. How to do that? Let's look at an example. We need to compare two different locations, and we need to find out which one is better for a photo processing company to open a new branch store. Okay, so here is a table. In this table, we have a list of factors. Okay, so we have proximity to existing source, we have traffic volume, we have rental costs, we have size, layout, and operating cost. For two different locations, they're probably going to be all different. Okay, so you can see that there, if you want to compare the proximity to existing source and the traffic volume, what are we going to do, right? We probably think that their oranges and apples is difficult to compare. Well, let's look at it. Now, for two different locations, we have location 1 and the location 2. That's two choices, alternative choices. So ALT as alternative. Factor proximity to existing source. We rank the location 1 with 100. That is, it's a perfect. Okay, if it is perfect, it's 100. If it is useless, totally useless, it will be 0. So location 2, we rank it somewhere in between. It's a little bit better than 50, so it's 60. 50 is an important line here. That means neutral. It's not good, not bad. Now 100 is perfect. Okay, traffic volume, both are pretty good. 80. Rental cost, location 1 is 70, location 2 is 90. Size, location 1 is 86, location 2 is 92. That means location 2 is a little bit bigger than location 1. Layout, this is qualitative again, so we rank the layout of location 1 as a 40, so it's not really good. 70, it's very good. Operating cost, this is a quantitative factor, so that's easy. We just calculate and we find one's 80, one's 90. Now let's look at factors again. Which one is a quantitative? Probably proximity to existing source can be quantitative. We can measure it by miles. Traffic volume, volume is quantitative. Rental cost, quantitative. Size, quantitative. Layout, well, this probably is qualitative. Operating cost, quantitative. So if we look at this list of factors, we have a mix of qualitative and quantitative factors. We rank all of them by in a scale from 0 to 100. Next, we assign a weight. We weight, for example, for the proximity of existing sources is 0.1. So this one is less important. Our traffic volume is the least important one because then we give it a weight of 0.05. Now, which one is the most important part? Rental cost, that is 0.4. Okay, size 0.1, layout 0.2, operating cost 0.15. Be careful. when we assign weights, we have to add them up and make it equal to 1. That is 100%. Another way to understand is proximity to existing source. The importance is 10% of all the weights we give to the all the factors. Then another one's rental cost, for example, is 40%. So it's very important. After we need to assign the weights. After we assign the weights here and the score here for each location, now we're ready. It is actually a very simple calculation. What do we do is we use the weight, for example, for the proximity of existing sources. Weight is 0.1. Score for location 1 is 100. Then what we do is weighted score for location 1. It is 0.1, comes from the weight, times 100, comes from the score for the location 1, equals to 10. So we do the same thing for location 2. The weight, again, is 0.1. Score for location 2 is 60, so 0.1 times 60 equals to 6. Calculate the weighted score for each factor. For traffic volume is 0.05, so 0.05 times 80 equals to 4. And the same thing for location 2, 0.05 times 80 equals to 4. Look at another one. For example, the last one, operating cost. The weight is 0.15, so location 1, the score is 80. So what do we do is 0.15 times 80 equals to 12. Then the next is location 2, the score is 90. So 0.15 times 90 equals to 13.5. After we finish this calculations, what we do is we add this column up. This column. For location 1, we add all the numbers here up. And we sum them up, we get 70.6. What is 70.6? Where does it come from? It equals to 10 plus 4 plus 28 plus 8.6 plus 8.0 plus 12. It equals to 70.6. We also sum up this column, and the total here is 82.7. From the calculation of a weighted score, we know that location 1, the weighted score is 70.6. Location 2, the weighted score is 82.7. Which one is better now? Which location is better? We find the location with bigger weighted score, obviously it's 82.7. So think about what we have just done in this example. Actually figured out a way to compare oranges to apples. It can be applied at a lot of situations where we need to compare oranges and apples. Even though we need to be careful about assigning the weight and rank the score. Those are very subjective. We have to be careful about that. But this method does give us a way to compare oranges and apples. Here is a list of the procedure to do the factor rating. I will leave that for you to read. And then these are as the procedure to follow when the next time you need to apply factor rating in some real settings. So you need to be rigorous and follow the steps here. The next method we look at is center of gravity method. Here's the example. We have 4 different locations, D1, D2, D3, D4. We need to build up a shipment center, a distribution center that will send out the products to these 4 locations. We want a center. Find a location for this center where we will have the minimal transportation cost for shipping all the products to all these 4 different locations. So the aggregating level of shipping cost. The D1 has a location with coordinates 2, 2. D2's location is 3, 5. D3's location is 5, 4. D4's location is 8, 5. These are coordinates. For D1, location D1, we ship out 800 units of products each week. Location D2, we ship out 900 units each week. And D3, 200, D4, 100. Now we need to find out a location for our distribution center. What do we do next? It's very simple. We only need to slow down and do some simple calculations. Now for location 1, D1, we know X equals to 2, Q, weekly quantity, equals to 800. Okay, so 2 times 800 equals to 1600. Y equals to 2, Q equals to 800, so 2 times 800 equals to 1600. Let's look at another one. D2, X equals to 3, Q equals to 900, so 3 times 900 equals to 2700. Y equals to 5, Q equals to 900, so 5 times 900 equals to 4500. We do the same thing for D3, D4, and we get the numbers here. What do we do next is to add up some columns. We added this column up. Summation of this column equals to 2000. The summation of this column equals to 6100. The summation of this column equals to 7400. Last step is again very simple calculation. We use the summation of this column, which is for X, equals to 6100, divided by the total here, which is 2000. It equals to 3.05. The summation of this column equals to 7400. So 7400 divided by 2000 equals to 3.7. Detailed calculation in the formula, it is this part, and this little part is the mathematical notation. If you don't like it, don't worry about it. Basically, we try to find a weighted average for X. We call that X bar, and a weighted average for Y, we call it Y bar. So X bar equals to 3.05, Y bar equals to 3.7. Now we're ready to give the center of gravity. As we calculated, the weighted average for X is 3.05. The average for y is 3.7, weighted average. Run it up to 1 digit after the decimal, we get 3.0 or 3.7. How many digits you want to run it up to? It depends on the situation. You make the decision. Okay. We take 1 digit after decimal, so 3.0, 3.7. D1 is here. If we map it, 2,2. The 2,2 comes from the table in the previous slide. D2 is 3,5. D3 is 5,4. D4 is 8,5. And where's the gravity center? Where's the best place for the distribution center? That is the 3.7 right here. This one we call that center of gravity method.